Hey guys, welcome back. This is day 5 of Simple Harmonic Motion. Now, today's class will be mostly about problems discussions only. Like, we'll discuss most of the problems, but the thing is, these are the problems that don't really fall in the order of teaching, because I teach something like I teach you about simple harmonic motion, the way it started, the way we entered the topic, and we solved a lot of problems. But the problems that I'm going to discuss today, they're not really in the flow of our teaching, but they're really important. Like, it's like you won't find these problems in maybe in HC Verma, not all the problems. Some problems you will definitely find in HC Verma, but some of the problems you might not. But these problems, they don't just fit in the normal way of teaching for me, so I don't really discuss in the teaching. I discuss them parallelly, like separately. Okay, right now I will do that today. In today's class we will be discussing those important kind of an ideas which completely won't fit into my teaching style, but they're really important. It's not like they're extra problems, they're totally important. There is a chance that you can get these problems. There are some problems just like these in yesterday's exam also, but anyway, I'll discuss them today so that you get some good knowledge. I've even noted some of them. Let's talk about them. Let's talk about one of those. I mean, all the questions one by one. I want some volunteers. Obviously, for the first question, says, uh, how do you tell an equation whether it is an SHM or not? Like, how can you tell? Like, Aditya, please raise your hand. Why did you go back? How can you tell whether an equation is as an SHM or not? Like, let they give you any equation. How can you people tell whether the equation is an SHM or not? That's the first question.
First thing, I mostly check do they consider initial phase difference or not, or like
No,
whatever
let
the
me just let me
equation
just
is
give you an
it is
example.
according to the phasor diagram. It
Let me
should
just give you an
completely fit
example.
in the phasor diagram.
You don't shut up at all. Let me give you an example. Where is Vamshi? Vamshi also. Like, guys, whoever want to talk about this topic, please raise your hands. The thing is, they give you a random equation. Let us say y equals to x. Y equals to x. That is the equation. Is that an SHM equation? First of all, it is not at all a displacement equation at all, because there is no time in it. The equation is not at all depending on time at all. So it's not an SHM equation. Leave that. Let us say I give you an equation saying y equals to t. The displacement y equals to t. Is that an SHM equation?
No, sir.
Why?
No,
Why
sir.
is it not?
It will not oscillate, sir. The motion will not be
First,
oscillating
so in
because it goes
the first place, it's not even
continuously, sir.
oscillating. Yes, it's not even oscillating. It's not coming back. As the time is going, y is also going.
It's going, sir.
Y equals to t square. Y equals to t square. Is it an SHM equation? Can it be?
No, sir. Again,
No,
Yes,
sir.
sir.
No, sir.
Yes,
Why?
sir.
like there will be two parallel values, but they will never oscillate, sir.
They're not
Yes, sir.
oscillating, right? Yes. But when I give you an equation saying y equals to sine omega t, a sine omega t, y equals to a sine
So
omega t.
there will be some
Yes,
oscillation
Yes, sir.
after
There
t
will
Yes,
be
sir.
The
square.
oscillation of.
displacement
There
is
will be a wave,
clearly,
sir.
yeah, the displacement is clearly starting from zero, going to positive extreme, coming to zero, going to negative extreme. So the displacement is clearly varying about a specific value. Yes, so this is an SHM. Now my question is, uh, let me write those equations one by one so that you get a clarity. Notes. Yep. Yeah. Oh no, I want to scribble notes. Wait a second, guys. Yeah. So when I say y equals to t, no, it's not an SHM equation. It's not even oscillating. Y equals to t square, or y equals to t cube log t, or y equals to e power t. If I give any of these equations, they are not varying as if they are oscillating. So none of these things can represent an oscillation at least. So we don't talk about them. But when I said y equals to sine omega t, or sine xt, or some sine zt, or sine mt, your call. But the equation y is depending on time. I can put any value here. I'm putting a only. So the equation is depending on time, and it is clearly oscillating in between a positive amplitude and a negative amplitude. So yes, this can definitely represent an oscillation. It's even representing an SHM. Now the next question is, can this represent an SHM? 5 sine omega t. Can this represent a SHM?
No,
Yes, sir.
Yes,
yes,
sir.
sir. Yes, sir.
Yes, sir.
It can happily represent an
It's the same thing, sir.
plus 5 and minus 5 are the amplitude, right?
Yes, sir.
Yes, sir.
Can this represent an SHM?
No, sir.
Why not?
Because the 10 is not oscillating, sir.
Okay, so
Yes.
So
But
it is
still it can
interfering with the
represent, sir.
oscillation of 5, sir. Like
what?
amplitude is not getting fixed. Like 5 is oscillating, 10 is a constant function.
But if I clearly observe this function varies from to plus 15 and plus 5. It is varying in between plus 15 and plus 5, taking 10 as a mean
But
position.
it is not coming to mean, na, sir. It's
No.
never getting
What
0.
what I'm trying to say is why is this not mean? Why could this not be a mean? Why can't we say 10 itself is a mean value?
So, but after
can
specific
take
time
that.
period, it should pass, na, sir. It is not passing only that way. It is not passing.
It will pass. It will pass.
It is correct, sir.
Starts from 10, goes to plus 15, goes to plus 5, 10, plus 15, 5. So it will definitely pass. As 10 as a mean, that's all. So guys,
Okay.
let me tell you, this can represent an SHM. Yes, definitely. Whenever I write y equals to some random value a2 plus a1 sine omega t. This part is an SHM equation, and this part is simply telling you that the mean position has shifted. Instead of having an oscillation about this point, we are simply having an oscillation about this random point who's a2. So we will have the same oscillation about that a2. So even if I draw the what do you call the displacement equation, for this it comes like this, for this it simply comes like this. So in the case of y equals to 10 plus sine omega t, instead of having time and y, instead of, we used to have displacement equation like this, right? But we simply have the displacement equation over 10, that's all.
Okay, you're just
Yes, sir.
There is no
shifting it
difference.
about.
The SHM is completely the same thing, except the mean position has shifted. So this is a thing that we never discussed, and it wasn't there in any of the textbooks that you've been doing, but this is an important thing. I think it is there in DVB. Did somebody come across a problem like this?
Yes, sir.
Yeah, now you get it. So 10 plus sine omega t. Now, let me give you another equation. You might come across a problem like 10 sine omega t plus 5 sine omega t.
So we can directly write 15 omega, 15
this
sin
is,
omega t, right?
Yes, sir.
Right,
15 it
15
is.
sine omega t. So yes, this will definitely represent an SHM. But
Excuse me, sir.
Yeah.
So we can just generalize this whole thing, right? There should be just a bounded value, that's it. Then it will be SHM.
Your statement is good. There should be a bounded value, but you will be bounded right now if I give you a problem. Like look at this thing. I just gave you pro example. You just proved that this is also an SHM since you simply can add it. But what if I say 10 sine omega t plus 5 sine omega t plus some 30 degrees or some theta? Can you say this is an SHM? This is one thing. What if this theta is all the way 90 and you have to write this as 10 sine omega t plus, I'm just taking an example, as and 5 cos omega t. If this is 90, if theta is 90, this will become cos omega t. Is this an SHM? That is the question now.
Sir, I think yes, sir.
No, sir.
I think yes, sir, because
Yes, sir.
both are
So for
both are
different
SHM
values,
equations.
different values will come.
Okay, now
Sir, I think yes.
They are not, sir.
Yes, sir.
first of all,
I think yes, sir.
no, let me tell you. I'll give you a glimpse of this. There is a subtopic called combination of SHMs. Combination of SHMs. There will be a subtopic. I like to teach this at the end of the topic because it doesn't really doesn't really go with any of the other topics. So that is why I try to teach this at the end of the topics. Now, the combination of SHMs I will definitely teach, but right now I'm just giving you a hint. We have the displacement equation. If only you differentiate it once. Why not differentiate once? Why do you leave it just why not differentiate it again and write it as acceleration? Once you write the acceleration, if it is proportional to minus y, can you actually prove that this is an SHM?
Yes, sir.
Yes, sir.
That's the
Thing
basic
that I'm telling
statement,
you.
na, sir.
Every time you feel you're stuck and you don't know what to do, you don't know where to approach the question. Why not simply differentiate the equation of displacement twice? Displacement differentiate it once, you will get velocity. Differentiate it again, you will get the acceleration. If the acceleration is looking like the acceleration is proportional to minus y, it's already in SHM. That is one way to do it. The other way to look at this problem, this combination of SHM, you are talking about combining two SHMs here. I will talk about it at the end of this topic. But yet, at any point you are given with a problem saying whether they're asking if it is representing an SHM, you always have an option saying differentiate it 2 times and check whether it is going to be a value like that or not. Get it now?
Yes, sir. It's
Yes,
there in
sir, got
DPP,
it.
sir, this differentiation.
What?
In DPP, one of the questions, the verbal differentiation was there. I was getting
Maybe,
confused
yeah,
there.
maybe, yeah. So that's it. That is one of the
Yes,
ideas.
sir.
Now, let's talk about the thing that Aniket was saying. The value has to be bounded. So if I give you a value saying y equals to, if it is y equals to a sine theta or a cos theta, I mean a sine omega t or a cos omega t or anything which is sinusoidal or cosinusoidal, it is an SHM. That we already know. This part we already know that this is an SHM. Happy. What if I give you y equals to a tan omega t?
It's not, sir. It
Why
can
is
go
it
to
It's
not?
not.
And
infinity.
sir, because
It
because
can go to
tan will not
infinity,
have
sir.
an oscillating curve, sir. It will
No,
go to
the
infinity.
simple thing you can actually
Some,
express, you can actually write it in terms of acceleration, write it d square y by dt square and prove it. Or intuitionally looking at it, tan doesn't really come back to a value. Tan simply goes to infinity. It's not a bounded value, like Aniket said. If it's not bounded in between a plus a and minus a, it just goes and goes away. It never comes back. So that's just an intuitional way to put tan value also. Like, yeah, tan cannot be a SHM equation. You get
So
that?
once can you prove it?
Now, why do I do it? Try. Why don't you just
Okay,
differentiate it? What do you get when you differentiate tan?
Secant square,
Secant
sir.
square,
Secant
sir.
What
square
do
omega
you
t.
get when you differentiate secant square again? You get 2
Secant
secant theta into
tan.
differentiation of secant theta.
Yes, sir.
So you get a large equation that is definitely not going as acceleration proportional to minus y.
Yes, sir.
Yes,
So that
sir.
is why you can prove it, or you can intentionally say that tan theta is not a value which is coming back, it is just going away. Same goes with logarithm equation, log omega t, let's just say, or e power omega t. All these functions are not bounded. They're not bounded in a specific value. They're just going away. So you can intuitionally simply say things like, no, it's not a SHM equation. Now, leaving that part out. Next, like Aniket said, I am going to take what do you call a limited equation only, but you people tell me whether this is a SHM equation or not. This is bounded clearly.
No,
no,
sir,
sir,
it's
it will
not.
like have
Sir,
a
it's not,
jump
sir,
in
because
between.
there will not be a negative
Negative is
extreme,
not
sir.
there,
Only
sir.
positive, sir.
What?
There will be only positive.
Negative isn't there, sir.
Oh, there isn't any negative.
Yes,
And
sir.
sir, if you see the graph, it will having a jump points after some intervals.
Yes, sir, it will go. It won't go to the
So one
negative
more
side.
reason is
After that.
there.
Okay,
So
first of
it's like
all,
x square, not x.
are you saying sine square theta graph will be like this?
Yes, sir. There will be no negative.
Are you sure about they be having like points like this? Or now this is where you people need to get your basics really strong. Are you saying the equation is like that, or are you saying the equation will be smooth only there at those points? How many of you are agreeing on point one and how many of you are agreeing on point two? Like for sine square theta, we are talking about sine square theta. Is it with one or is it with two? Anybody?
So we weren't taught in math
I
science.
think it's one, sir.
You
One
weren't taught how
No,
sine square
sir.
theta looks?
No, sir.
You
Also, it is
stupid
taught, sir.
boy.
dot, sir.
Taught, sir.
Of course, Aniket lies all the time. Whenever he gets in a corner, he simply blames it on the teacher. Do you blame it on me also sometimes, Aniket?
No, sir.
Then, so yeah, you people tell me whether sine square theta goes with one or goes two. Like,
Sir, I
is this
think
a
one.
graph or is this a
Two,
graph for
sir,
sine square theta?
actually.
Do you have a sharp
Yes,
curve or do you have smooth edges all like just like smooth?
Smooth edges, sir.
It
Smooth
will
edges.
have.
Then
Smooth, sir.
No, sir, I think it will have a
The
sharp curve.
second point,
Not I think
sir.
Sir, smooth, sir. Sorry, sir. Smooth.
Ganesh says a second only, smooth only.
Sir, me also second.
Aditya is also agreeing on
Yeah,
second.
now I realized, sir.
Sir, I first.
Now
Sir,
you
I think it goes with one, sir.
Me too,
Suman
sir.
Raj goes with one. I think it is two only.
Sir, why, sir?
Why? What do you mean? Why? Like,
Why
why do you
not
get
one, sir?
sharp edges? Like, why don't you people tell me this? Y
The
equal.
sharp edges only happen when we have mod in it, not a square.
Okay. That's a good way to put it. Like, answer this question. Y equals to a cos square omega t.
Further it will be sharp.
Sure, not
Do
SHM.
you people remember cos square theta can be written in any other forms?
Yes, sir. Cos square theta
Yes, sir.
minus sin square
1
theta.
minus sine square theta, we can write it as.
1
What?
minus 2 sin square. 1 minus 2 sin square theta, sir.
1 minus
Sine
sine.
square theta only,
No,
sir.
sir.
Only sine square
Sin
theta.
square theta, sir. 1 minus sin square theta.
Anything in terms of 2 thetas? 1 minus cos 2 theta or 1 minus sine 2 theta? What is wrong with you people and your basics?
1 minus cos 2 theta by 2,
Oh
sir.
yes, sir.
1 plus
What?
cos 2 theta by 2.
First of all, your basics needs to get strong. 1 minus cos theta, 2 theta by 2, 1 plus cos 2 theta by 2. Do you people remember these things at
Yes,
Yes,
sir.
sir. Yes, sir.
Then why
Yeah.
you not answering me that way?
I said, sir.
Okay,
1 minus
somebody
cos
has
2
some
theta
good
by 2.
knowledge. Please raise your hands and speak about it.
Sir, I knew it, sir, but I couldn't type it in the
Then
chat
give me the
section.
right values now. 1 minus
Sir,
cos 2 theta by 2 equals to?
1
plus
plus
co- 1 plus 2
1 plus
cos
cos
theta
2
by 2.
theta by 2, sir.
1 plus cos 2 theta by 2 equals to what? What is
Cos square theta,
Cos
sir.
square theta,
Cos
sir.
square
this? Is
theta.
cos square theta. What is this?
That is,
Sine square theta,
Sin
sir.
square theta.
Sine square theta.
Ganesh, Sharath,
yes, sir.
is this sine square theta or not?
It is sine square theta, sir.
I
It's sine
can't
square
believe I'm
theta.
making you people do this.
Sir, I just didn't
So,
speak because others were
so
speaking, sir.
when I have an equation, even cos square theta, or when I have an equation saying sine square theta, I can convert this into simple sine 2 theta, which means sine 2 omega t or cos 2 omega t. So, can these equations represent SHM or not?
Yes, sir.
It can, sir.
We have to
They can.
Yes,
differentiate
sir.
and see, sir.
No, sir. Like that also we can say it represents.
Okay. This stays as a question for you people because of your stupidity in your basics in mathematics. Let's just keep this question as a question for today and tell me whether these two things, sine square theta and cos square theta, if I write a cos square theta or if I write a sine square theta, are those equations SHM equations or not? You people have to tell
Excuse
me.
me, sir.
Yeah.
So here only we can say, right, it's of the same form like the previous ones.
So tell me whether it's an SHM or not.
It is, sir.
It is
Yes.
an SHM.
Yes, sir.
Who else is agreeing with Aniket? No one else? See, Aniket.
No, sir.
But I know it is, sir.
No, sir. Like we can convert again. Like we can convert sine square omega t to sine. Like we had that right.
Okay.
2 sine omega t cos omega t.
Take some time on this question. Take some time on this question and actually come back with a solution saying whether we can
It
use
is,
cos.
sir. It is. It is.
No, sir. It isn't.
It
Okay.
is. I differentiated and see, sir.
Why don't I post an Instagram poll on this and fight with you people? Anyway, leave it. I'm not answering this question. Like you people come back with an answer tomorrow, maybe. Okay.
Okay,
Okay,
sir.
sir.
So you need to tell me whether these equations are SHM equations or not. So we looked at different equations which are not bounded in between two specific values. They're definitely not oscillatory equations at all. They're just going away. And then we looked at equations like a plus sine theta, where you have the shift of mean position. Where is that equation? Yeah. Shift of mean position kind of problems. Then we came to discuss the combination of SHMs. We will discuss these things later. Then I discussed tan theta since it is not even bounded. It's not. I'm asking you whether the sine square theta and cos square theta equations are SHMs or not. Now, you being stupid people, you being the best students in the class, which is so sad, you can't even tell the difference between this graph and this graph. You're not even sure about whether sine square theta graph is like that or this. Get a clarity on that. And yes, this is a question for you today, whether this equation can represent an SHM or not. Okay. Once we are done with this, I think, yeah, you will get these kind of problems only. They give you different problems and you should be ready to tell whether an equation is an SHM or not. You always have a advantage saying, try to differentiate the equation with time, 2 times, try to find the acceleration. check whether the acceleration is directly proportional to displacement with a negative sign all the time. Sumantra, you have a doubt?
No, sir.
Yeah. Now, after this, I just wanted to discuss all these type of questions. After this, the thing that I have is, yes, the phase and the phase different type of questions. We've discussed these questions a lot. Like, yeah, you people can tell me no matter which particle I give you, you can happily give me the phase and phases, right? So in an SHM, this is a mean plus A and minus A. Why don't you people give me the phases? A particle is at A by 2 plus A by 2 going towards. What is the phase?
So it should be
One
120 degrees, sir.
120.
It is
120.
150.
150, sir. 150.
150, sir.
150, yeah.
120
Why
is
I take
here.
90 plus?
Oh, sorry, 120 is somewhere around here for root 3 A
Yes,
by
sir.
2. And then 135 is for A by root 2 and 150 is this angle. So I hope you remember all these angles, like how to give these angles, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Now
This
let
one.
me give you a problem. One particle plus A by 2 moving away, another particle minus A by 2 moving towards the mean position. What is the phase difference in between them?
60 degrees.
60 degrees, sir.
That was quick. Good. Anyone
Perfect.
else? Everyone's agreeing with the same answer?
Yes, sir. 60,
Yes, sir.
sir.
60 degrees.
So let me draw the phasor diagram. Here is the mummy. Sorry, here is the baby. So here is the mummy. Here is the mummy. You get 30 degrees for this. You get 330 degrees for this, which means this is 30 degrees. So the phase difference is clearly 60 degrees. Okay, let me give you another problem. These problems are important because you'll clearly understand why. Somebody has a doubt? Mean one particle is at plus root 3 A by 2 moving away. The other particle is at minus A by root 2 moving downwards. What is the phase difference? Quick.
Sir, 60 and 45.
115, sir. 115 degrees.
One is here, so mom's here.
Should be
Yes, sir.
315 degrees, sir.
115.
Down.
So it
Yes,
will
sir.
be like
It
60
should be.
degrees. And
It
this,
should be 45, sir. It would be
45, sir.
45.
this is here,
315.
right? The mom is here, which is at 225 degrees.
225 degrees.
So it is the difference in between these two will be here it is 45 degrees, here it is 90 degrees, and here this is 30 more
165
degrees. So
degrees.
120. So 165 degrees is the phase difference. Okay. I mean, if
So
you're
one
not,
doubt.
yeah, who's that?
Should we take the smaller angle, sir, or the bigger angle?
It doesn't really matter. If there are both the answers are there, you can take the smaller angle. That's just a notation, but it shouldn't really matter. If you say the phase difference in between them is this part as 165 degrees, it's totally right. You take this angle as how much is this angle? The other angle will be 205.
195, sir.
190.
No. Yeah, 195. So 195 is also a good answer. Or you can say things like, let us name them as A and B. B is leading A by 165 degrees. B isn't leading by 165 degrees compared to A. Or A is leading B by 195 degrees. Both the statements are totally fine. Okay, A is leading by B 195
Okay,
degrees,
sir.
and B is leading by A 165 degrees. As long as they don't mention anything other than this. If they mention other facts, like you won't face these facts right now, you might face these facts in the topic of waves, then it matters. There are situations like you will find a phase difference between two particles as 1,000 degrees, which means it already went 3 oscillations ahead. You getting my point? Like it already went 3
Yes,
oscillations
sir.
and the second particle then started. It went 3 oscillations and the second particle started. So there is a chance like that. If they don't mention anything, both the answers are totally fine. They always go with the smaller answer. It is just a notation. It's just a thing people follow. So it is good you follow that also. Let me give you a question. So there are two particles. Directly I'm giving you mom positions only. So the babies are at this position and plus root 3a by 2 mean. Okay. What's the phase difference between them?
60 degrees,
60
sir.
degrees.
60
Straight up
degrees.
60 degrees. The question will be like, after what time will they meet each other?
So it depends upon the frequency, sir.
They give you a time
But
period
they'll
also.
never
Whether
meet.
the time period is
Like now we have to take the LCM of the time period then. Okay
no,
then.
both the time periods are equal. Both the time periods are equal, and the
LCM of time period, sir.
So
LCM of
if
time
both time
period.
periods are equal, they'll never meet.
will you please listen to me? Both the time periods are 8 seconds. So the moms will never meet for sure. I'm asking about the babies. I'm asking about the projections. When will they meet? When will the babies meet? You know the difference, right? The babies will oscillate like this.
So when the moms are parallel to each other.
Yes, you got the point. Aniket, you are very stupid sometimes, and sometimes you are really good. Look at this thing, guys. I hope you can see me. This is the angle before, like this is where the initial case is like both are at, one is at mean position, the other is at 60 degrees. But when they're like this, the projections will meet. So I will draw the position. Aniket, is that what you meant, or
Yes, sir, that's what.
was it just by fluke?
No.
So when this goes here, when this goes here, so at some point they will be like this. So the projections will be exactly at the same point. So at this point they will meet. Now we know the position, we have to find the time. Like be careful, every time they give you a problem like this, you always need to be careful saying the particles should, what do you say, like a mirror image, how do you put it? Symmetric, yeah, you can say simply symmetric. So if the particles are symmetric out about that point, about y-axis, which means it has to be 30 degrees, it has to be 30 degrees, since the total was 60 degrees in between them. They exactly have to make 30 degrees about y-axis, and that is when they meet. So to make it 30 degrees, let us look at this particle. This particle, it has to go out all the way to make 30 degrees. So it actually traveled 60 degrees. It actually traveled 60 degrees. So this traveled here, this traveled here. That is when they met. That is when they met. So for traveling 360 degrees, they take 8 seconds. For traveling 60 degrees, it's nothing but 8 by 6 seconds.
So they have to travel by the phase difference value.
No. Here, coincidentally, they got the same value. Let me give you another question. It makes more sense to you people, okay? One particle is here, other particle is here. Like they already have a phase difference of 90. So one is at mean, the other is at already extreme. So what is the phase difference in between them? 90 degrees.
90, sir.
So I would say the babies, the projections would only meet when
45.
it's like
40.
45 degrees, which means the first particle has to travel only 45, the second particle has to travel 45. So you have to find the time to travel 45 degrees.
One question, sir.
If the angle is given 120 degrees, they have to exactly be split by 60 degrees, 60 degrees. So that is how you do all these problems. Okay. Aditya,
So
what?
one doubt.
Yeah.
So if we want to do this in equation form, can we do?
I think it will be really difficult in the equation form. That is why I always follow this method only. Doing it in equation
sir.
is like you'll have to take all the possibilities, to put possibilities of sine, all the possibilities of cos. That will go on that will take you on a very long path. So I don't actually suggest that. Okay.
Okay, sir.
Yeah. Any more doubts? Anybody?
No, sir. My doubt was I only cleared myself. I gave it a thought once.
Good. So these are the kind of problems sometimes, and sometimes problem like, yeah, there is a problem. Find the point at which the separation between the particles is maximum. Like check this thing, check this question only. Initially, Aniket, what does your intuition tell you? Like the particles are here, the projections are here. Is this the maximum separation in between the particles that is possible, or is there a chance of more?
So there's chance of more.
At what point? In my opinion, this is the case. Like when they are symmetric about x-axis, the separation in between them is the maximum. Do you feel that?
Yes, sir.
Yes, sir.
So yeah, there is a question like this also. If you want them to meet, they must be symmetric about y-axis. You want them to have the maximum separation, they must look symmetric about x-axis like this in this case. So they have to travel all the way, like it has to travel all the way here. It has to travel all the way here so that the separation becomes a maximum. So this is another problem of a kind in this.
So can you show an example on this?
You want to show another example?
Yes, sir, on this one.
Okay, please.
No, sir, can you show?
Oh, can you want me to show? Okay.
Yes, sir.
Why not take that 60 degrees thing only? Take the 60 degrees thing difference only. Like one is here, mean position. The other is at plus root 3a by 2. Some sound is coming from someone. I don't know who that is. Please, can you go on mute? If you have a doubt, please raise your hand and I'll clear it. Okay. So this is the case. Now, in this case, to get the for them to meet, they have to be symmetric about this axis. For them to have a maximum separation, I think they have to come to a position like this. Aniket, I hope it is clear. Okay. Aniket, did you die? Okay. So this is a case where you get the maximum separation. This is the case where the particles meet. Here the particles meet. Here the particles will have the maximum separation. So you'll have like 30 degrees about x-axis for the maximum separation, 30 degrees above y-axis for the particles to meet. That is the difference. Okay. Sai Charan is in the waiting room. Yeah. Yeah, Aniket.
No, sir, nothing.
Now you get the point now?
Yes, sir.
Yeah. So that is one more style of a problem that I wanted to discuss. So that is also clear. Let me look at other problems. No, the other problems are easy only. Let us talk about energy a bit. You people have already, like we already discussed how to write the kinetic energy and potential energy, right? The
Yes,
kinetic
sir.
energy is nothing
Yes,
but
sir.
half kx square, or we expanded it into a problem saying half m omega square a square sine square
Sin
omega
square
t.
omega t.
Sorry, why did I write this as a kinetic energy? This is potential
And
energy.
total.
Potential, sir.
The kinetic energy goes like half mv square, and when you expand it and write it, you can write it as half m omega square a square cos square omega t, right? This is the potential energy, this is the kinetic energy. They ask you equations like, they ask you a question like, if omega is a frequency for an SHM, what is the frequency for the energy? What is the frequency of oscillation of energy? Like, I'll show you what it is. If I write displacement time graph, let us say the displacement time graph is like coming like this. So it is repeating itself after a specific time period that is called as a time period. Like we all know this, at t, at 2t, at 3t, it is repeating. But if only I write the kinetic energy or the potential energy with time, it comes, let me draw the guided lines so that I can match them properly. Do you see this? I'm not drawing any sharp curves. All of them are smooth. Can you see it is actually repeating itself after time t by 2 itself? So the time period is half for kinetic energy, and if you talk about frequency, it is doubled. If the frequency here is f, the frequency here is 2f.
2F, sir.
Exactly.
Okay.
It goes the same with the potential energy also, except the potential energy graph looks a bit different. Like it's as if it is shifted by a little amount, but it again is a potential energy graph is also frequency is 2f. Can somebody tell me by what frequency the total energy changes?
It won't change, sir. It's constant.
That's good. The total energy is a constant value. So if I have to write a total energy versus time period, the graph is constant. So it does.
Right hand parallel to x-axis.
So you don't even define such thing as a frequency for total energy. Okay, you can define that thing for potential energy and kinetic energy, but do not define such thing as a frequency for total energy. So that is the thing for energy equations, energy problems. Now, uh, yeah, shall we discuss this? Let's look at a problem saying a spring block system. It is having, we already know, we already talked about it at mean position, positive extreme, negative extreme. In the beginning, we told ourselves saying the potential energy here is zero, kinetic energy is max. Here, the potential energy is max, kinetic energy is zero. Potential energy is max, the kinetic energy is zero. You all agree with this thing?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
But this is not exactly a mandatory thing. Need to tell you, this is not exactly a mandatory thing. The potential energy doesn't have to be zero. This is the thing which can vary where then there is
Mini shifted, sir.
well,
We
exactly
have a
there is an
constant
external
force.
force instead of this mean position. We have this as a mean position. External force is there, so there is already a kx not present. About this position, it oscillates. Let us say the problem here is at the mean position, the spring is already compressed by x naught. So even at the mean position, there is a chance for potential energy. So remember this point that the potential energy is not always zero at mean position. Potential energy doesn't have to be zero at the mean position all the time. It has to be a minimum value. Has to be a minimum value. You will slowly understand these things maybe in further cases. Mm, like there are complicated cases, but let me show you something. Let me show you a problem like, how do I show it to you people?
So how should we solve such problems?
You
It's
don't
there in
solve them
DBP
with
also, sir.
you don't solve them with energy. Let me give you an example. Okay, like there is this problem saying, I think it's a problem that was sent to me by who's this guy, Sharat, I guess. In that problem, potential energy is given as, normally what is potential energy? It must be half kx square, right? That's all. If k is like 10, so potential energy must be 5x square. That's all.
Yes, sir.
But in that problem, the potential energy was given as something like 5x square plus 4x plus 2. Guys, let me tell you, this also can represent an SHM equation.
Force is varying, sir.
It looks strange. No, force is
There
not.
is a constant force, but it will
Force
have a
is always
parabola.
varying. Force is always varying. It's not about that. Let me show you that. Let me show you a best example. Like, guys, is this a parabola? Like,
Yes,
Yes,
sir.
sir.
let me draw
Yes,
it
sir.
properly. Let me draw it properly. This is clearly a parabola. You all agree?
Yes, sir.
Yes, sir.
But would you people say that this is not a parabola?
This is also a
No,
parabola.
This is a
sir.
parabola.
Everything is.
Everything is. So that is the only difference. Like this represents a parabola like this represents a parabola like this. That's all. Except the minimum value is not zero. So where in a case where the potential energy minimum case is not zero. That's all. That's the main difference, mathematically speaking. Theoretically speaking, like even at x equal to 0, the potential energy of particle is u equals to 2. You see that? So even at the mean position, the potential energy is not completely becoming 0. So there are cases like this. There are theoretical cases. There are practical cases also. We can't really completely jump into those kind of problems at this moment. We are not that professional and in this.
Sir, it can't be negative, right?
It can't be negative. No, no, no.
Okay, sir.
It's
Sir, and
your,
one more thing.
wait a second. It's really your call. Writing potential energy as negative. Like I said already, potential energy can be varied. It's about the variation of potential energy. It's not really the value of potential energy all the time. Okay.
Okay, sir.
Yeah.
So how to find for this one?
Yeah, I'm getting there. So every time they give you a potential energy equation, I'm just talking about the theoreticals only. The practical problems we can't really get into right now. And every time they give you potential energy equation, every time they give you u, if you all remember this thing, u is integral minus f dx or f dr. So you simply write minus dou u by dou x, it will get you the restoring force. So no matter what kind of a potential energy they give you, Try to differentiate this, you'll get the restoring force. Once you get the restoring force, the problem is done. So every time they give you a potential energy equation, let us take this example only. U equals to 5x square plus 4x plus 2. Okay, try to differentiate it. Du by dx. So 10x plus
Next
4.
plus 4, sir.
Plus 4.
10x plus 4. So minus, wait a second, minus du by dx is minus 10x minus 4. So from this restoring force is written, so you will have all the problems that are like, you can simply solve the problem. This constant is simply representing this external force. That's all. So you can simply
Sir,
take,
so we can equate to kx.
yeah, you can equate this value to k and solve the problem normally. I really want to show you some practical examples, but this is not exactly the right time, I feel, because you people are not that ready to face such problems at this point.
Sir, so when will we get them?
Once you're proficient with this topic. But
Like
for
end of the
now,
week, sir.
yeah, so it is never.
Oh, okay, sir.
No, see, thing is, like, whenever you have a potential energy equation, simply try to differentiate it. You get the point. That's all. Try to differentiate it. You get the restoring force. Sometimes like the problems are given really easy. Like they give you u equals to 10x square plus 2. Try to write minus du by dx. So you get minus 20x. That's all. So restoring force equals to minus 20x. This is nothing but k. You solve the problem and that's all. Aditya, I have a doubt.
Here
No, sir.
means
I
there
have
is no
one.
external force, right, sir?
What?
Excuse me, sir.
Here there
One,
is no external force, right, sir?
No,
In
there is
this
no external
problem.
force. Yes, but Aditya was saying something. Wait a second.
Sir, actually, I was saying, why should we find the restoring force? If I like, can you go for the graph one? I have one more method. Once can you cross check like I am thinking right
No,
or not.
no. Please don't dig into this part yet.
One second, I want to like that the minimum value of potential energy, na, sir.
Uh-huh.
At that point, we all know the slope is 0. So I will find that directly slope is equal to 0 and find the minimum potential energy.
Okay,
yes, sir.
you still don't know all the cases yet. So that is why I'm not like, by the time we get to some really good cases, you will actually, you're actually we will be capable of giving a problem like this. Like you can give a practical example like this. Then you'll understand it by yourself. Okay. Until that point, please don't confuse others. Okay.
So can you go down once?
Okay.
Sir, this example, this 20x1,
Mm-hmm.
where is that plus 2 coming from then, sir?
Again, like the way you define the potential energy at the mean position, you already defined at the mean position that the potential energy is already 2.
Oh, okay, sir.
Okay. So that is the
Yes, sir.
point. That is this constant is representing. That is why, like if you people are really good at parabolas, like you know what parabolas mean, how they represent all the real life
No,
cases,
sir.
then it will be much easier for you people to understand this. That's why I'm asking you people to stop thinking about it at this point. Okay.
Okay, sir.
Don't jump into the topic completely, but you need to understand that thing, that a potential energy equation can look different, can look strange, and whenever it looks strange, try to simply differentiate it, try to write the restoring force, try to find the time period from that. All right. Yeah. The next thing that I wanted to discuss, frequency part, I discussed. Time period part is nothing but time period of energy is 2f. Yeah, but the frequency of energy is 2f. I discussed this part. The potential energy is not always 0 at mean position. Yes, I discussed an example like this. Now this part, shall we discuss it now? What is the time? 2:59. I think, yeah, let me just give you one more problem. Let me just slip in one or two more problems. We can do it. The thing is, how do you deal with problems like when the mean position is shifted? I'll give you some problems like uh, this is a problem. The natural length is this, but because of the weight, the spring has expanded by some x naught. The spring is already expanded by some x naught. So there is mg acting, there is kx naught acting. This is a new mean position. This is a new mean position. Aditya, you have a doubt?
No, I have an answer for it.
This is a new mean position. We've already discussed that whatever happens, whatever the kind of oscillations that you will simply have about the new mean position. That's all. It is
Yes, sir.
not a strange thing anymore. But they give you problems like, let me take a new page. They give you problems like, they put two masses. Because of those two masses, this new mean equilibrium position already shifted to some other point by x naught. So you will have some kx naught. So the blocks will actually be at this point, and this weight is m plus m into g because both the blocks are present. So this is the new equilibrium position. What they do at this point is they remove this block suddenly. So there is a new equilibrium position. So this is not even the new equilibrium position. You will get a brand new equilibrium position, which is only at a distance. Here the distance is actually what? This x naught is because of m plus m into g. So m plus m
Yes.
into g by k. But the new equilibrium position will be only because of mg by k only, because the small m is removed suddenly. So this is a completely new equilibrium position. But the problem here is, they say when the blocks are at the extreme position, like when the blocks are at this first equilibrium position, they suddenly removed it. So it is as if the block wants to oscillate about this equilibrium position, the new equilibrium position only, the final equilibrium position only, making this part as an amplitude.
So
What is
x naught minus x.
exactly x naught minus, this is like x naught dash, let's just call it as x naught dash. So this value will be like m plus mg by k was a total elongation. From that, if you remove that, which is mg by k, mg by k, you will get this separation. So that is the amplitude of the problem. This is a weird problem. I mean, I don't completely like to discuss this, but I hope you understand that.
Yes, sir.
Yes,
It's
sir.
as if the body, that this is an equilibrium position, like this is a final equilibrium position, so no doubt about that. But the body is still present at here at this point because it was suddenly removed. So this remaining block is still present at the extreme. So this part, whatever the part is left, it will take that as an amplitude and oscillate. And also, guys, when you come across problems like this, please don't take it as a new problem. It's exactly the same, except the spring is not elongated. Now the spring is compressed. That's the only difference. There is no difference at all. Okay. So you can look at some of these problems also. And I wanted to
Because direction of force doesn't matter, right?
yeah, exactly. Exactly. I wanted to discuss one more thing. Did I discuss the cutting of a spring? Like whenever you cut a spring,
No, sir.
No, sir.
No,
the
sir.
spring constant becomes 2k and 2k.
No, sir.
No,
No,
sir,
sir.
not
Discuss
this.
this.
You only discuss about that series and parallel arrangement of
Yes, sir.
spring.
So in
Right.
kinematics, you told this thing, but
In kinematics, I did, right?
Yes,
yes,
in
sir.
kinematics you told.
Yeah, in kinematics, I did like whenever you split a spring and what you need to do and all. Like I explained it, right?
Yes, sir.
Yes, sir.
So then it's fine. Like when
So once can you just explain if we have like infinite number of pieces?
like let us say you cut a spring into different spaces, k1, k2, k3, k4. The thing is 1 by k1 plus 1 by k2 plus 1 by k3 plus 1 by k4 must be equal to 1 by k effective, which was the original spring constant.
Yes, sir.
Yes.
So when you do this, you will get each value of spring constant. So you do the same thing with a single spring also. You split it. If only you have 2k and 2k, that's when you can write 1 by 2k plus 1 by 2k equals to 1 by k effective. The k effective will simply be k if you calculate this.
Okay,
So
sir.
cutting of a spring is not a big deal. Whenever you cut it in half, the spring constant becomes 2k, 2k. You split it into three parts, it becomes 3k, 3k, 3k. It is a simple thing. Okay. But to get a better perspective at it, we will talk about this in the topic of properties of materials. Okay. We will talk about that and you will get a complete clarity why a spring constant actually increases as you cut it. Okay.
Okay, sir.
Oh yeah, since that is also handled, I'm giving you one more homework today. The idea of simple pendulum. Like, give me your views on it. How is a simple pendulum? I'm already giving you a point saying the oscillation of simple pendulum is like very, very small. So small, it's not even like this, it's a straight line. So you people tell me how, on what assumption, on what point are we actually considering this as SHM? We should
So
consider
maybe
this
it's
as an
vibrating
Sir, the
continuously.
spring is
Definitely
inextensible, sir.
What?
Spring should be inextensible, sir.
There is no
So maybe it's vibrating. That's why.
no. Try to do it mathematically. Try to prove it mathematically. Okay.
So
Now, I'm telling you, if the oscillations are this
SHM.
big, you cannot take it as an SHM. I'm repeating it again and again. You should not take this as SHM. The oscillations is like very, very small. Then only you can consider it as an SHM. Okay. So, if you complete that, I will introduce simple pendulum to you people tomorrow. I hope you are completed with all the problems that I asked you, like all the basic problems in this page 17, 18, 19, 20, 21. Did you people try that?
last
Some
two
of
are
them I
left for
said,
me,
some
sir.
of
Yeah,
them I
then
tried.
try more today. But coming to the problems in this page, they're a bit difficult. Not difficult. They're a bit of a new idea. So I will I will discuss them maybe in the next class. I will introduce simple pendulum. I will discuss some problems from simple pendulum. We'll move on to the further ideas. All right, guys. So thanks so much. Before I end the class, just regarding the class, are there any doubts?
No, sir.
So that sine
No.
curve is, it will be curved, sir.
Yeah, but please prove that whether
Sir,
science.
I can prove it right now, sir.
No, don't do it. I have to end the class. I have to be somewhere else. So
Okay, sir.
we will talk about them tomorrow. So thanks so much, guys. Thanks so much, and we
Thank you,
will
sir.
meet again.
Thank you, sir.
All right. Thanks so
Thank
much.
you,
Thank
sir.
you, sir.